that the only thing that has to be constructive is the basis. So if you put back the screwed in the middle, you should get back to classical model logic. But you might think that there's something more constructive about the modalities themselves, and that putting back the screwed in the middle does not get you back exactly to the classical model logic. And of course, we do kind of want meaning of the meaning of the modality with respect to the intuitionistic modality being sound and complete. That's kind of goes without saying. So the only difference really is on this business of adding the screwed in the middle. Now, Amnon Avram, because he's a philosophical logician, has a different desiderata. He says that whatever intuitionistic model logic is, it should be able to handle the great diversity of logics, especially the traditional ones. It should be independent of any particular semantics. So this business of having different semantics proved equivalent, it's not something he cares about. He says, and I agree very strongly, that the structure should not be too complicated, and they should yield a real subformula property. Yeah, we all want that. And he also says that rules of inference should have a fixed small number of premises and a local nature of application. And yes, that would be great, because that would certainly give us a better understanding of the logics and the difference between them. But you know, this is a desiderata that's much more about what we actually want than about what we can get. And this big discussion about the diamond over disjunction, if it should be the case or not, it's a complicated one, right? Because, you know, in CS4 it doesn't hold, but in IS4, which is Simpson's system, it does hold. So this distribution is canonical for classical model logics, and it's not sure.
I've seen twice that we have this distribution of possibility over disjunction, and then possibly bottom yields or entails bottom. Are those proven to be equivalent somehow, or are they just supposed to be related?
Good question. No, they're close related because one of them is just a nullary form of the other, right? Look at that. If you take the A or B and you make both A and B empty, if you think of an empty A or B, you have false, and then the other side you get this side you get diamond of false, and the other side the negation gets just false. So one is the nullary version of the other. But the fact that one is the nullary version of the other does not mean that everyone, like me, thinks that they should go together. Because my perspective is much from algebra, so I think, you know, if you have the operator, you have to have the nullary version and vice versa. But the student of Nerode who first thought about these things using constraints, hardware constraints, said, I need to have the box, the diamond false equals false, but I don't have to have the nullary distribution. So a very recent paper that I think was presented yesterday in Leaks, it's about exactly, I'm telling you about two families of logics. One that satisfies this distribution and the other one that doesn't satisfy this distribution. But recent work has shown that actually there is a whole continuum between the two. And I wouldn't know that if it wasn't because a friend of mine is in Leaks and sent a picture of someone talking about this continuum between CK and IK. So, don't take what I'm saying now as granted because I haven't read the paper. I just saw one picture of this result. But since you asked about it, it's just that's what happens is that mathematicians think that operations should come with their unities, and lots of times people don't think so. Yes, please.
Speaking of the diamond as possible, it seems like the diamond A or B has gotta imply diamond A or diamond B. What if you can give the intuition behind the other take on that? Maybe why wouldn't that be?
That's a good question. I should go back and make sense. I don't know if I understood completely your question, but I think it's a very good question and one that I worry about at night lots of times. Because, because you see, the thing is, when you're just thinking of it as syntax and you get something that is diamond A or diamond B, you don't know how you could construct something on top of that, because you don't know if you should go to the left or to the right if you're being constructive. You need to go in one of the two directions. So I cannot see, it's a problem that I also have with not A proving A. If you ask me to prove A proves not A, I know how to do it. I start from A implies A, and I do the natural transformations, and I get an evaluation function. But the vice versa, as far as I'm concerned, is just magic. It's just because I want a symmetry that I cannot construct for you. So the same thing happens here. I put this thing and I think, how do I know in which direction I'm going? Right? So it might be lack of imagination on my part, but for me, that's is a problem. So let's kind of try to finish. So yeah, this distribution is complicated. It's canonical for classical model logics. Many constructive systems don't satisfy it. And I don't know if it should be required for constructive ones or not. And if you insist on that, then you get back classical model logic. But, and that's a new result of Anupam Das from Birmingham and Sonia Maran and Lutz Strasbourg. There is a blog post about that in the proof theory blog, showing that the system that I called CK, I always thought that it was that if you add the distributions these two distributions, then you would get IK. But they proved that no, there are things that are not proved in this system. Sorry, let me kind of rephrase that. They proved that there are formulae that do not include diamonds, and that they are proved in IK and not proved in CK. So the distribution is not all there is to the difference between the two systems. Another difficult with that is whether you believe, the Simpson system has a different kind of assumption. So this is the traditional assumption, this one is the traditional rule that we've been looking at. It's more complicated than the one we looked at carefully, because as you can see, it's worse, right? The previous one we had that if there was a box in the assumptions proving an A, then with the same box in the assumptions you would prove a box A. Now both sides of the sequence are changing at the same time. If gamma proves an A, then box gamma will prove the box A. So it's less pure, it has no symmetry on the other side. What Simpson says is that he's kind of thinking of the meaning of, meaning of box in cryptic semantics. And the meaning of box in cryptic semantics is that, if I'm in a world that proves A, and all the worlds that I can see from this world also prove A, then I actually can prove in the world that I'm sitting in the box A. So what he's doing is building up a different sort of assumption that is much more semantic, that's dealing with the accessibility relation. So he has two kinds of hypotheses, and that's your question over there, right? Because, do you accept this sort of different kind of assumptions? Are they good enough, or do they have to be just of the style that Gensen invented? So, how reasonable it is to have your proposed semantics as part of your syntax, and how good it is to think about different kind, I mean, how much weight do you put on the idea of different semantics? If you remember, Arnold did think that you should have different sorts of, that the system should be agnostic with respect to the semantics. So it's an inch. Sorry, you want to say something?
Yeah, I was just wondering how we should think about box gamma, since gamma is like a collection of elements. Does it kind of distribute to each one, or how do we think about that?
Sorry, I didn't get it.
How should we think about box gamma? Since
It's
gamma is
box
like a
in each
collection.
one of the things. That's how that is. Sorry, this is just a convention. Everyone uses the same convention, so I kind of forgot to mention.
Okay, thanks.
Yeah, but when I... So sorry, the convention that I forgotten to mention is that whenever I say box gamma, I mean box, each one of the elements of gamma has a box in front of it. Sorry. Sure.
Why is the left rule okay? Because it's clearly not structural.
You're talking about Simpson's rule, this one here?
The one on the left.
This is because this is K, not CS4, the one that we're looking at carefully. So this one, it's a weaker system than the one we were talking about earlier on. And what it says is that you actually can change both the antecedent and the consequence in a single rule. So it is a, yeah, I find a rule difficult to process myself too. But this is the rule for K in traditional model logic. Okay, so the other thing is that, you know, the systems with the labeled assumptions kind of can model many more things than the systems that I was discussing before. So, you know, they have the ability, they are better if your measure is number of systems modeled. But they don't have categorical semantics associated to them. And, I should be finishing, but, so the modularity of the systems is kind of important. And I don't know how much you think that that's the main thing. So Avram thinks that, you know, there are logics, nice, simple semantics, and simple semantics for him are cryptic semantics, and all those interests for which no decent cut-free formulation seems to exist. Larger but still satisfactory frameworks should therefore be sought. So we're all kind of looking for them. Now this is the state of play, or it was the state of play some 5 years ago. You have the intuitionistic ones which have this extra crypt-like assumptions on them, and you have the ones without it. And they are not completely proved. I thought they were. When I kind of produced the slides, I thought they were. But then I discovered that some of the lines here are not guaranteed. And I'm not going to talk about schools of intuitionistic model logic, I just want to conclude. So, constructor model logics are interesting for programmers, logicians, and philosophers. It's still a shame that they don't talk much to each other. There are at least 3 families: CK, IK, the ones that I just showed, the cubes, and the Fitch systems that I actually went over very quickly and didn't talk much about, but they are the ones that actually have many more applications in type theory. And they have different properties. So it's hard to produce good proof theory for them. And there are many augmentations of sequence systems and many type theories. And this was a preliminary conclusion for myself, that IK system seems better for model theory and for this number of systems that you can model. CK seems better for the Lambda-Calculus to a certain extent, but Fitch seems better for the pendant types, because that's the extra bit that I didn't introduce so much so far. You know, a system is good if it kind of can be extended to more powerful systems. So if, you know, without dependent types you don't want to do anything, then maybe you just get get rid of the diamonds and just use boxes and do whatever you can with them. And with that, I think I tried to show you a panorama of Curry-Howard for constructive model logics. There's much more work that I didn't talk about, and there's lots of work on applications. And I'll leave you with this question. Is an overarching framework possible? Is it desirable? Kind of some food for thought. I'd be very interested in hearing your thoughts and questions and stuff like that. Thank you. I'm sorry, I just forgot to show you a picture of Per Martin Löw. I thought, that's absurd since we kind of talked about him all the time, and that he is in Oberva, and that's me.